Okay, so I have just made a commit and push for today's lecture. It should appear, and again, to kind of pull it, okay, you'll change into your, this is me pretending to be a student, okay, you'll change into your local repository, 2024 SP Stats 21, and, oops. So currently I just have lecture 2-1 in there, and what you're going to do is, assuming you have your remote repository set up, you're going to do git pull upstream main. Okay, git pull upstream main, and that should pull the latest content, which will be 2-2 functions in python.ipynb. All right, and that should be the latest content. If you're getting an error there, that probably means your upstream repositories are not set up correctly, and I don't want to spend time right now going over that, but if you come to office hours, I will help you, okay? I will help you get everything set up and squared away. I've seen some questions on CampusWire, and it looks like you guys are helping each other out, which is great. So thank you for that. And again, the way you open up files, all of these IPynB files, you can't just double click them, all right? You gotta start up either Jupyter Lab, which is kind of my preferred thing, or some kind of IDE that is able to handle IPynB. So popular IDEs that exist other than Jupyter Lab are things like VS Code. You can download and install VS Code. When you install Anaconda, I think it comes with Spider. Spider is kind of I don't know if they've copied RStudio or what, but there's a lot of similarities between Spider and RStudio. So that's another popular IDE. And then Jupyter Lab is just another IDE, but it runs in your browser. And so you have to basically start up that program. IDE is like what? Interactive developer, I don't know, something like that, okay? You start up Jupyter Lab, you start up VS Code, you start up Spider or something, and then from there you open up the file, okay? You open up your IPynB file. And so you'll either navigate to, this 2024 thing. As far as your homeworks go, okay? You'll want to, I strongly recommend saving your homework files into a dedicated homework directory. So, on Brew and Learn, I have the homework files posted. Don't open up your homework files from your downloads folder. Okay, you click, you see, homework 1 instructions and whatnot. So you'll download this thing. Your browser defaults to downloading to your downloads folder. Okay, your downloads folder is probably cluttered with a whole bunch of stuff. Okay, a whole bunch of stuff. So don't put your homework folder files in there, okay? At least at the very minimum, create a dedicated homework folder and put it in there. And I strongly recommend having a separate homework folder for each homework. So you'll have a folder for homework 1, a folder for homework 2, a folder for homework 3, because sometimes you have supporting files, and you'll want to just put them in there. And then from Jupyter Lab or whatever program you're using, you'll navigate to that folder, okay? So, wherever it is. So here, I have my homework folder. I'll go to homework 1, and I can open up the folder there. Right now, I'm in my 2024 Spring Stats 21 folder, and I'll open up my my Jupyter Notebooks there, okay? So that's under here, under the file browser in Jupyter Lab. Again, whatever program you want to use, that's fine. This is one that I know works decently well there, okay? And again, if you're still having issues with any of this stuff, come see me in office hours, okay? And then when you create your homework folders, or just whenever you create files and folders on the computer, get out of the habit, don't use spaces, but use either dashes or underscores, okay? Use dashes or underscores, and that will just make typing out file names navigating your via command line a lot easier. And then, you know, even just like if you ever create a website or something, all of those things are just easier. So no spaces, just use dashes or underscores, okay? Or camel case. Okay, but let's go ahead and take a look. We're talking functions in Python today, okay? And so this is what it comes down to. Basically, all programs out there can be reduced to the following instructions. 1 is get input. 2 is produce output. Okay, so input could be getting input from Kyle, a keyboard, a file, network. Okay, so either on the internet or something, or some device, maybe a game controller. Okay, and then output is display data to the screen. Okay, save it to a file or send it over the network. There's going to be some kind of math calculations, mathematical operations are performed, and then there's a lot of kind of conditions. What do we do next? All right, based on if this is this, then what do we do next? And then repetition. Usually repeat the same thing, but maybe just slightly different. And that is every single program out there, every single program. So you think of your most advanced video game, okay? That's a lot of fun and whatever. It's just the same. It's all exactly the same. It's just input, output, math, conditional execution, and repetition. So basically there is a lot of math going on though, because you have a screen, maybe you know, you have a 4K screen or 1080p screen, and you just have a whole bunch of pixels, okay? And there's a bunch of math that goes into what color should this one pixel be, okay? And it has to do this at least like 60 times per second. It needs to calculate what color should this exact pixel be, and it figures that out. And and that's based on the input from the controller. The math includes basically like what the camera's looking at, where on the map are you, what is happening, and then it calculates what color every single pixel should be. It's doing billions of these calculations every second, and by changing those colored pixels, you get smooth motion, and it looks like you're in some new imaginary world and things like that. Okay, maps, all of that stuff. There's a lot of information and data stored. Okay, in terms of like where your GPS program. There's a lot of kind of information kind of stored. I guess the information is just but basically math, and it just says, where what should I display here and things like that. Okay. And so how are all of these actions executed? We use functions. All right, and we call a function, and that executes the function. You can think of a function as basically the action verb. And so function call, the way we ask the computer to execute a function is we write the name of the function, and then we put parentheses, and we put any kind of arguments inside those parentheses. And a lot of functions return some kind of value. And so in this case, we will run the function type. All right, that calls the function type. The argument we're going to provide is 42, the integer 42, and type will tell us what type of data has gone into this function. So here I'm going to hit Shift Enter. I think when I committed to Git, it had all of the responses filled in. If you want to kind of do it, you can restart kernel and clear all outputs, which is what I've done. And I hit Shift Enter, and it says, okay, the value of the type of value that we have here is it's an int. Okay, it's an int. Okay. If you do not use parentheses, you are not calling the function. This is just the name of the function. Okay, and it is. It just refers to the object. Okay, it's the difference between telling somebody, the action of running, telling somebody to actually start running, okay, the verb, versus saying run, which is now just a reference to the physical, and not the physical, just the conceptual word, R-U-N, okay? And so here, P-R-I-N-T without parentheses does not call the function. It just says, oh, this is the object run, object print, okay? Here we can call the function. We can say print with parentheses. We put in the argument hello, and that calls the function, and this will print out hello to the screen. Okay. Here I can say print 1, 2, 3, 1, 2, 3. I'm providing multiple arguments here, and this prints out the values 1, 2, 3 on the screen. There's other arguments you can provide. There's an optional separator argument. And so now when I print out the values 1, 2, 3, it separates them using a dash rather than the default space. That's that, okay? You can always kind of reference help. You can physically do this. You can type help print, okay? Or you can use the command Control-I for contextual help, or you can go to the menu up here where it says help, and you can do show contextual help here, right? And also under help, there's links to kind of Jupyter references, and you can kind of, okay, so here, now it's giving me contextual help on help, but here we can get it on print and whatnot, and again, it shows you, the different args, if you see star args, it means it can accept a variable amount of arguments. And then there's other ones like the separator end file, etc. Different kinds of arguments you can provide, and this provides more details regarding what those different arguments mean. Okay, so that's helpful, right? If you run help print as a cell, it will show that same exact kind of help information from the manual pages. Documentation pages here as well. Okay. As far as defining a string, you can use single or double quotes. Whatever you use to open should be the thing that you use to close it. If you open with double quotes, you can put in single quotes as apostrophes. So here you got I can't believe it, and that works. If you open with a single quote, then it does not allow you to use a single quote as an apostrophe, because the interpreter sees this single quote as closing off this one, and so you're going to get an error message, okay? It says unterminated string literal. It says, I don't know, this line, I don't know what to do here, okay? So if you want to use an apostrophe within a string that has open and closed with single quotes or something like that, you can escape it using a backslash, okay? And similarly, if you wanted to use a double quote within a quote, like you're quoting somebody and you wanted to include those quotation marks, you got to escape it with a backslash. Okay, how do we define a new function? Okay, we define a new function using the keyword def for defining of a thing, and basically you write define the name of the function that you want to create, parentheses, any kind of arguments, and then colon. And then once you do that, the indentations will indicate all of the lines associated with that function definition, and as soon as you stop indentation, that basically closes it off. Here, if you want to have your function return something, you have to use the keyword return. So here I'm going to create a function called shouting, and it's going to accept some kind of argument. The argument is going to be assumed to be a string. Strings have a method called upper, and that just takes whatever input you have and it makes it uppercase. All right, and so what we're going to do is we're going to take whatever string it is, make it uppercase, and we're going to add 3 exclamation points. And it's interesting, whenever your brain sees capital letters and exclamation points, your brain reads it as somebody shouting, okay? So here we have it. We're going to do shouting and then quote, hi, my name is Miles, and then just note how your brain interprets capital letters, right? And so if you see all caps, this, hi, my name is Miles, exclamation, exclamation, it feels like we're being shouted upon, okay? Shouted at. You can put in, if you put in something that's not a string, like the number 5, what it's going to do is it's going to take 5 in as the phrase, and then phrase.upper is going to try to make this uppercase. Now, 5 is an integer. Integers don't have a method called upper. So if I try to run this, I run into an error. It says attribute error, int object has no attribute upper, okay? And so, with integers, you can't say, hey, give me an uppercase 5, right? That's confusing to ask for. So it gives us an error. So we have a few things that we can do, and one is we could take whatever argument we have and we could wrap it with this function called str. And str is basically going to attempt to make a string version of whatever input object you have, okay? So here we can take in, if phrase is already a string, then this just leaves it as a string. But if phrase is something like an integer, it's going to try to give us the string version of that thing. So here is just a small modification, and we're going to just wrap the word phrase in the function string to get that. We run that, and then I'm going to do shouting on 5 here. So now that I've redefined shouting again, okay, this old definition just kind of poof disappears, okay? So there's the name shouting, and it used to point to this definition of a function. Here I've created a new function definition. I've given it the same name, shouting. Shouting now points to the new definition of the function. The old definition of the function just kind of goes away now. So here I can do shouting 5, and now I have 5 exclamation, exclamation, exclamation. And it seems like we are kind of shouting out 5 in excitement or something like that. Okay. I have not given you any answers yet, or have I? No. Okay. I'll go ahead and give you your first view quiz answer. The letter E. E as in elephant. E as in elephant. All right. If you use something like return, okay, then you can take the output of your function and assign it to an object, okay? So we can say shouting hi, and I can store it, set it equal to greeting, okay? And so now this name greeting is going to point to whatever shouting hi returns, okay? So this is going to be a string, which is basically hi, exclamation, exclamation, okay? If you forget to use return, then this object, this is not returned, okay? This is the function returns a none, okay? The function returns a none. And so, we're in R, this is actually the preferred style, is that it returns, whatever line you write last in your function. It doesn't work that way in Python. You have to use return. So if you just put in the object at the very last line, it's going to return nothing. So here, if I say make quiet, so this phrase quiet takes whatever phrase you have and makes it lowercase. Here we're gonna do quiet on hello here, and we're gonna store this output. Okay. What is whisper? Okay, whisper is a none, and if you actually try to say, hey, what is this? Like nothing gets output to the screen. Okay, Now you can say print whisper, and it will print out none. And you can say, hey, what is the type of whisper? It's going to be none type, okay? But the default for what this outputs is not to actually show anything. If you want to actually see the word none, you have to call print on the none object. So the none is kind of like in R, the equivalent of null, but basically it's just nothing is there, okay? When you get a none object, that represents the idea that nothing is there. And so calling for whisper here, you get a none type. So if you actually wanted this returned, you'd have to change this to return, and now you can get it, okay? And now this is going to be hello and string and things like that. But if you leave that off, you get none and none type. If with Python, you can have functions return multiple values. What it will do is it returns, it groups those values together into what's called a tuple, okay? And we will explore tuples in a future lecture. It's a kind of a very useful data structure. I wish we had tuples in R, but we don't. Very useful data structure. Basically, it just gathers things together into something like this, okay? So here I'm going to say create a function called powers of. We're going to take in some kind of argument that I arbitrarily called number. There's no inherent meaning to using the argument name number. There's no check here that says is a number, so I could do like powers of and put in, quote, apple, and I'll just run into an error message. So there's nothing about using the name number that says it should be numeric or something. And maybe to the user who sees this, they'll say, oh, okay, this is a cue to me that I should be entering some kind of number. But there's nothing inherent in Python that says this has to be a number. Okay, but I'm going to do number, square it. That calculates the square. Number to the third is going to calculate the cube, and we're going to return the number, the square, and the cube. So I can do powers of 3, and we're going to get 3, 9, 27, and this is grouped together into a tuple. The parentheses, opening and closing parentheses, indicates that this is a tuple. One nice thing about tuples is there's something called tuple unpacking. You can take powers of 3, which is this tuple 3, 9, 27, and you can assign it directly to x, y, and z, okay? And so Python is going to see this and says, oh, you want me to assign this tuple 3, 9, 27 to x, y, z, and it's going to do that, right? It'll assign everything kind of respectively. And so now you can ask, what is x? X is going to be the value 3. Y and z are 9 and 27, and so on and so forth. If you wanted to, you don't have to unpack them into 3 separate values. You can do powers of 4, assign it to j, and now j is that one object, that one tuple that contains 3 values. So you can say, what is print j? And you get, it is the tuple 4, 16, 64. If you want the individual values within this tuple j, you can reference them. And Python uses zero-based indexing, so you can do j square bracket 0. So this is much like referencing a value, a vector in R. So in R, you can do square bracket subsetting to say, hey, I want the first value, I want the 8th value, whatever you want. Same kind of thing in Python, except it's 0 indexed. So the first position is the 0 index. So j square bracket 0 will give us 4. J square bracket 2 will give us 64, so on and so forth, okay? One key difference is if you do, say, j square bracket 10 or whatever, this will give you an index error. It will say that index is out of range. In R, what happens if you reference a position in a vector that's out of range? It returns NA, okay? It's a kind of a curious behavior of R, but that's how it decides to handle out of range indices for vectors. Okay, it's different for lists and things like that, but if you try to say, hey, I want the 10th thing there, you're going to get index out of range. Okay, Now, to perform tuple unpacking, the number of elements to unpack must match the number of values being assigned. So remember, powers of whatever returns a tuple of length 3, and so you can unpack it to say 3 values, x, y, z. But if you try to unpack it to say gh, then Python is going to error out. It's going to say value error. It says, and one nice thing about Python, again, read the error messages. A lot of times it will tell you exactly what is going wrong. Okay. Now, there's a caveat there, is once you start using packages like pandas and NumPy, and you run into problems, a lot of times it'll be like something has happened deep within the pandas or NumPy code, and those error messages are a lot harder to read. But when you're writing your own kind of functions and stuff, the Python error messages are actually very, very helpful. And so here it says, hey, look at this line, gh powers of 5. There's too many values to unpack, right? It says I expected 2 because you told me we're going to assign values to g and h, so I'm expecting 2 values to unpack, and I would give the first to g and the second to h. But when I ran powers of 5, I had 3 values, and now I don't know what to do, right? It's kind of like 3 people show up, and you only have 2 seats in your car. What are you going to do? Okay, now you have a problem, and that's what Python is saying. Okay. Let's keep going. Flow of execution. So this is kind of obvious, but the order in which you write your code determines how your code is going to run, right? Execution always begins at the first statement of the program, and statements are run one line at a time in order from top to bottom. Now, when you define a function, okay, defining a function just creates the definition of the function. The statements inside that function definition do not run until the function is called. So you create a function definition, and so it's kind of like, all right, in case of this, like when I tell you, like, here's the plan, right? So it's kind of like when you're making a plan with a friend and you say, here's the plan, you're gonna go to door number 3. Okay, your friend doesn't run to door number 3 as soon as you say you're going to go to door number 3. You say, when I say run the plan, that's when you go. Okay, and that's basically what a function is. You're saying, here's the plan. When I tell you to run or execute, then you run these things. Okay, but it'd be really frustrating if you're trying to say, this is the plan, and as soon as you say the words, they start doing it, right? I think that's used for comedic effect in certain movies and stuff like that, but that's what a function definition is. So you set this up, and it doesn't execute until you tell it execute. Question, yeah.
If lists unpack in the same way that we'll do, like when would you ever really need to, like, what is?
So lists are mutable and tuples are not, and so that plays an important difference. I'll get to it later, okay? But basically, mutable objects can't be used as hashes are unhashable, and they can't be used as keys in dictionaries and things like that. But anyway, that's later. But that is a good question, because it does feel like, oh, lists can do more than a tuple. Why would I ever want to use a tuple? But there are cases where you want the limited functionality of a tuple over a list. But future lecture, okay? So yeah, a function call is like a detour in the flow of execution, and instead of going to the next statement, the flow jumps to whatever the function is doing, runs the statements there, runs the plan that you had come up with, and then comes back and picks up where you left off. Okay. All right. So parameters and arguments. All right. So this is all bad code. Okay. And I write bad code in these things, or we have illustrations of bad code to illustrate the things that go wrong if you don't do things right. Okay. So anyway, here we got this function called print twice Bruce. Bruce is the name of the argument coming in. Okay, and these are not great names. Okay, and we're going to print Bruce. So that's simple enough. Okay, so we can do print twice spam. This is all of this obsession with spam is the original author was a big fan of Monty Python, kind of this British comedy troupe, and you know, there's a bunch of kind of classic movies and stuff like that from Monty Python, and you know, they have a song about spam and things like that. So anyway, if I write print twice and I put in the argument spam, spam comes in as the argument Bruce. We're going to print Bruce twice, and we're going to print spam out twice. Okay. Here we'll import math, and we're going to do sine of pi over 2. That comes in, and it's going to print that twice. So sine of, you know, pi halves is, you know, top of the circle. You get 1.0. Print twice spam times 2. Spam space times 2 itself is going to be a string that says spam spam, and we're going to print that twice. So we get spam space, and then a new line spam space, spam space. Okay, what's going to happen here if I do print twice spam? Okay, so here we're going to print twice. So whenever you read functions, start on the innermost and work your way outward. Okay, so the innermost function is print twice spam. Okay, and that's going to output spam. And then we're going to print twice whatever this thing returns. So what happens here is we print twice spam. Okay, that's basically this thing up here. And then print twice spam returns a none. Okay, and so now we're going to print twice the none object. Okay, so we get spam, none. All right. Okay, so after we've run this, the output of print twice spam is none, and so that's basically what's going on there. Okay. Second view quiz answer is the letter C. C as in cat. C as in cat is your second view quiz answer.
Sorry, guys.
Yeah.
I was lost in the math part, like the 1.0, 1.0.
Uh-huh.
Was the math dot.
Yeah, oh, okay, so pi halves is, this is a different class here, but you get your unit circle, and you start off at 0 radians, and this is what, pi radians, and this is, pi over 2, and then we're up here, unit circle with sine. Sine is this value, which is 1, okay? Yeah. So what is sine of pi over 2 is 1.0, and we're just going to print out 1.0 twice. That's all. Sorry, it's probably been a while since you've had to see trig functions, so it's like, yeah, well, how does my unit circle work, right? Okay, let's let me keep going. I got a lot of these things to do. Okay, you can set up default arguments. If you don't set up default arguments, so this is just the dumbest function. The function is called stuff, and it takes in 3 arguments, ABC, and it's going to just print out ABC. So you run stuff 1, 2, 3, and it prints out 1, 2, 3. Now, because it's expecting 3 arguments, if you only give it 2 arguments, it's going to give us an error. It's going to say, I was expecting, I got a 1 and a 2, and I put that for A and a B, but then I was expecting a C, and I didn't get that. So stuff missing 1 required positional argument C. Okay, you can fix stuff like that by writing a function with defaults. Inside the arguments, you just provide equal sign and the default argument, and that's what's going to get executed. So here, if I provide no arguments, then it uses the default 1, 2, 3. It's very similar to how R behaves, with a couple caveats, so a couple of differences. If you use 4, it goes in as the first one. You can specify B equals 4, and then B gets the 4, and it uses defaults for everything else. If you give it all 3, then it goes, the first value gets, A, then B is 10, and C is 0. Now, if you start using off something like this, then it's going to complain. If you give it a positional argument, then it's going to assign 5 to A, and then it's going to see A equals 10, and it's going to get angry with you. And it's going to say, hey, you're giving me multiple things for argument A, and I don't like this. Okay, I don't like this, right? You can do this, and that's fine. Okay, you can give the arguments out of order, and it says, okay, fine. C is 5, A is 10, and B is 0. Fine, I'll accept that. Okay, but if you do something like, hey, 5, it's going to read that reading left to right. It says, oh, first argument should be 5. A is 5, and then it says A is 10, and it says, nope, I'm not going to do that. Okay, here is just another thing. We got print twice. It's going to do print Bruce, okay? here I've got cat twice, okay? And we're going to take part 1 and part 2. It's going to combine part 1 with a space and part 2. So basically, it's going to concatenate them together. And then we're going to call print twice on whatever this cat is, okay? So I don't know if you guys know this Selena song, Bitty Bitty Bum Bum, but anyway. So you can do line 1, Bitty Bitty, and then line 2, Bum Bum, and then you'll put those together, okay? And so we'll cat twice line 1 and line 2, and then when we call cat twice, it's gonna cat those together, cat, and then it's gonna call print twice on whatever that cat is, and so it's gonna print this out, okay? And that's how we go. Okay, now when this function finishes, okay, the variables that were created inside here disappear. Okay, these only exist within the function as that function is running. Okay, if we try to ask, hey, what was cat in the global environment? It says, hey, that doesn't exist. If you say, hey, what was Bruce? Because remember, that was an argument name here. It says, well, yeah, that doesn't exist either. Okay, so so those things don't work. Okay, now I keep saying this, and I can't emphasize this enough. Read through your error messages. When you encounter error messages, don't just throw up your arms and say, it's broken, I don't know what to do. Okay, read through your error messages. All right, so let's try to figure out what happens here. Okay, so here I've got print twice Bruce, and I'm going to do print cat, cat twice, print part 1, part 2, cat, print twice cat. And if I do this, I get this error message, right? It says cat twice, line 1, line 2. This is throwing an error. And so now it does this trace back, okay? It says when I try to execute this, this is the error I encountered, okay? So it pulls up the definition of cat twice, okay? And it says, hey, when I ran this function, I ran an error. I ran in a line at this thing, print twice cat. And then when we open up the definition for print twice, I run into an error on line 2, print cat. And what is the problem I have? It says name cat is not defined. So it kind of goes through the different, like, what line were you running? Okay, this is where we encountered the error message. It pulls up the definition of this. It traces through these things, and it pulls up the exact location. And then we can see, oh yeah, you know what? Within this print twice definition, the argument coming in was Bruce. I never defined cat. Cat doesn't exist in the global environment, and that's why we're running into this error. Okay. Now, if I still had kind of this poorly written code here, I could try to run this, but here in the global environment, I can have a value called cat, and this is something else entirely, okay? And if I run this, then I won't encounter an error message. However, it's probably not what I expected, because what's happening is I run cat twice. Within this function, cat becomes bitty bitty bum bum, but then when I execute print twice on cat, okay, it runs Bruce here. Bitty bitty bum bum comes in as Bruce, and it's going to say print cat. Here it doesn't find cat within this definition here, and so it searches the global environment and then it prints something else entirely. Okay, I've already forgotten. Did I give you 1 or 2 view quiz answers so far? 2. Okay, I will hold off on giving you your third until the end. Okay. You have a few kind of magic commands. These will tell you like what are some of the arguments that exist within the global environment. So you can say %who. These are the names of the different variables that we've defined that exist in the global environment. Who_s gives you some more information. This tells you not just the variable name, but its type and the values inside of this. If you use an IDE like Spider, then you'll have a pane, a separate kind of window pane that kind of has these environment variables available, kind of showing up at all times, which is, a handy feature as well. Okay, and then you can also do %whols, which provides these things as a list. And so you can kind of like reference to things within the list itself. You can do who ls square bracket 4 or whatever if you needed to. Okay. Python has scoping rules, which are similar to the scoping rules of R, which maybe you covered in your Stats 20 class, maybe not. Basically, the idea is values inside the function only exist within the function, don't really interact with the things outside of the function. But if it can't find something inside a function, it will search the higher scope for the thing. So here I've got x is 5 in the global environment. Okay. Here I got alter x, where we're going to add 1 to x and store that in as x, and we return x. So when I call alter x, it returns 6. However, this operation x plus 1 equals x only affects the x inside this function and not the x in the global environment. So the global environment value is still 5. Okay? If you want to, you can use this keyword global, and that will say, you know what, alter global x, and basically rather than taking x in as an argument, you use the keyword global and it says, hey, go to the global environment, find this variable x. Now I'm referencing this global variable x in the global environment, and we want to kind of alter that. Okay, so here x is 5 in the global environment. I'm going to call alter global x. It returns x, which is 6, and it has also altered the x in the global environment by using this keyword global. Be careful. Be careful with this keyword. It's I hesitate to even show it to you because I really don't recommend using it, okay? But you will see it in code, okay? And it's important to know that this functionality does exist. But you can start a lot of times when you start using global variables, you can end up with a lot of unintended consequences unless you're very careful with the. You can just look up like, should I use global variables in Python? Okay, and you'll find the first hit. Why are global variables evil? Okay, I don't know if I go so far as saying they're evil, but certainly they can be dangerous. Okay, so just be careful. Just be careful. Okay. In this Python, we'll ask Python to print the value of x, and in this case, it's going to kind of search for x, print x, and things like that. And so here, it looks for x in the global environment. It prints out 6. It also returns x in the global environment. Okay. This is the priority order. This is the LEGB. Okay. So first, it's gonna. This is how Python searches for variable names. It's going to first search for something in the local environment, okay, which is the function. There's something called an enclosing environment, and that only exists if you have functions defined inside other functions, okay, which you can have. So if you have a function defined inside another function, and you search for something in this internal function and can't find it there, then it will search for the function that is enclosed inside, okay? And if it can't find it there, then it will go into the global environment, the global scope, okay? And then finally, if it can't find something in the global scope, then it goes into the built-in scope. Built-in scope has all of the functions that exist as far as like base Python. So things like the function that defines what is a list, that's part of your built-in scope. And so obviously you don't need to create a function called list. If you do create a function called list, that will take precedence because that will be in the global scope. So when you reference something called a list, then it's going to look for that. It's going to find the this list function that you've created in the global scope, and that could lead to problems. Okay, these are just examples. You can run them on your own time. That kind of goes through some of the different things within Python. So here I've got x, y, and z in the global environment. We can change y to 2 in the local thing. This does not affect anything in the global environment. Okay. Here I've defined a function g inside of f. Okay. And so when I look for x, y, and z, it's going to find z in the local, then y in the enclosing, and it's going to print out 1, 2, 1, 2, 3. but then the global values are unchanged, okay? And I have all of the kind of supporting statements here, okay? Here, F is in the global environment, G is defined in the global environment, and so, so when I call F, and it says return G here, okay? Even though I have y equal to 2 here, when I execute G, I will get 1. It's going to pull x from the global. It's going to pull y from not F, okay? It's going to pull it from the global. So we're going to get 1, 1, 3, even though I have 2 inside of F, because F is not the enclosing scope of G. It is just another function, and they're both defined in the global environment. So when you can't find something in, we can't find y inside here, it's going to just go to the global environment. Again, all of this is kind of explained away here. Here I use the keyword global, so now we modify things in the global environment when I say z equal to 3. So the 3 in the global environment gets changed, and we have stuff like that. Okay, so anyway, all of these kinds of things, these affect stuff, okay? All right, let's, we'll wrap things up here, and I will give those of you in person the final view quiz answer.